Today we begin our study of trigonometry, and we are going to begin with defining what trigonometry is. And trigonometry is triangle measurement. Alright, so with trigonometry being the measure of triangles, we're going to focus on the measure of angles. And talk about, we have two angles here. We're going to discuss where do we start measuring and where do we finish measuring. And on the counterclockwise side, the part of our angle that is pointing directly to the right, that is our initial side. And then the other side of our angle that's pointing down and to the left, this is the terminal side. And that's where we end. So initial's where we begin, terminal's where we ending. We think about something terminating, that would be the end of something like a job. Okay, so the way we're going to measure is we're going to measure counterclockwise, the opposite of the hands of a normal clock, and so it would go this way. And when you do this, your angle measure is a positive measure. And we're going to be measuring in degrees. And this particular angle is about 225 degrees. Now, if we measure our angle clockwise and go to the opposite direction, things change a little bit. So we're still going to have the same initial side. This is where we begin. And we're going to go counterclockwise like this to our terminal side. And when we do this, we have a negative measure, negative degrees. And it's really about the direction that we measure our angle, and this one is about -60. So if we measure our angles counterclockwise, it's positive, and if we go clockwise, it's negative. Now, standard position talks about where our initial side is. And when the initial side of our angle is on the positive x-axis, we call this standard position. Now, and so it would look something like this if you had your xy axis, if your initial side pointed this direction. Now, quadrantal or quadrantal angles are angles that talk about where the terminal side is. So when your terminal side of your angle ends on a coordinate axis, then we call it quadrantal or quadrantal. And so an example of that would be, here's my xy coordinate system. If your initial side still was in standard position and you had an angle that ended sitting on an axis. And so that's what we mean by quadrantal. Now, before we go through these examples, I'd like to first begin with talking about angle measures. Going all the way around a circle is 360 degrees, and that's what we do here. So is your initial side, you're starting at 0 degrees. You go straight up. This is 90 degrees. This is 180. And these are 270, and it would be very good to learn those. Also, the quadrants. We start counting our quadrants with 1, 2, and it's always counterclockwise, 3, and 4. Okay, now we want to sketch each angle in standard position, and 210 is a positive degree measure, and we're going to go counterclockwise, and 210 is somewhere between 180 and 270. So we're going to start with putting our initial side on, and then we're going to follow it around about to where I think 210 would be, and I think that's it. And then we'll do our terminal side, like so. Now this winds up in the third quadrant, so I'm going to write 3 for third quadrant. Okay, now example 2 is a negative 180, and that means it's going to be a vertical line actually, and it's negative, so we're going clockwise. Let's put our initial side on first. We're going to go clockwise all the way over to the opposite side, and then put our other arrow. Now this one does not wind up in a quadrant, and it's quadrantal. Like so. And the arrow showing the direction is necessary to show that this is a negative measurement. Now example 3, we have a measure of 330 degrees, which means that it's going to wind up somewhere here between 270, which is this, and 360. Also, this is also 360. So we're going to put our initial side first, follow this around till about 330, about right there. Put the little arrow to show direction, and then sketch your terminal side. And this one winds up in the fourth quadrant. So we're going to sketch in standard position the angle described and then find its measure. 2/3 of a counterclockwise revolution. Now we're going to start with our initial side. And so if we could divide up this XY coordinate into thirds, you would probably end up somewhere around here. And it's a counterclockwise, so you're going to go this way. And it's right there. Now how would we figure this out? Counterclockwise means it's going to be a positive measurement. And so 2/3 of something means you're going to multiply it. So we're going to multiply by positive 360. And this gives us 240 degrees. Now 1/6 of a clockwise revolution means you're going to have a negative measurement. So if we could divide this up, this motion right here, that's 1/4 of a revolution, so 1/6 is smaller than that. So we're going to put our initial side, going to come around about like that, and that would be a pretty good sketch of 1/6. So since you're a negative, we're going to, instead of a positive 360, we're going to do a negative 360. And so this would be a negative 60 degrees. Alright, coterminal angles. Angles in standard position with the same terminal side. This means that they're going to start in the same place and end at the same place, but not necessarily go around your x-axis the same amount of times. So an example of this is if you have an angle that goes this way, it's positive. But if you measure it the other way, it's negative, but they end in the same place, but they have different angle measures. So that's what coterminal means. So let's do an example. Basically what you're going to do is add and subtract 360 multiple times. You're going to keep from the angle that you're given. And the number of times that you add and subtract we're going to represent with an n. So it would be 35 degrees plus 360 n. Number of times that you're going to go around. So n can be positive and negative, so I'm going to let n equal positive 1 first. So that means we're going to spin it around one time, and that gives me 395 degrees. Now, I'm going to go the opposite direction, so I'm going to let n equal negative 1. That means we're going to spin it clockwise one time. So we'd have 35 minus 360, and that's a negative 325. So I found two angles coterminal with 35 that are positive and negative. Now we're going to do the same thing with a negative degree measure. Format's the same. You take your initial degree and add 360 in every time. And let's spin it around counterclockwise once and see if we'll wind up with a positive angle. And so that gives me 260. So I found a positive. And let's spin it around the negative way once and see if we get a negative angle, and we will. So that's negative 460. Alright, so we found a positive and a negative for this one. Okay, now let's look at 1,000. 1,000 means that our angle has an initial side here, and we spin it around a few times. So if you have one of these, you need to spin it around a few times. So our formula is going to be 1,000 plus 360 n. Well, if we used n positive, we're just going to keep getting bigger. So we need to subtract. So we're going to use negative n's. So I'm going to start with n equal negative 2. So I have 100, or 1,000 actually, minus 720. And that equals 280 degrees. If I subtract 360 one more time, I should be able to get a negative angle. So I'll have 360 times negative 3, and that equals negative 80. So I got one positive, one negative. So basically the key is keep adding and subtracting 360 until you find one that works.